Hello racers, and welcome to today's video. In today's video we are going to do a review of the Rocket RC V3 10.5 spec motor, stock spec motor. So first question you have is, why are we looking at V3 motors when Rocket RC has version 6 already? Well, the reason I got these motors is these are the lowest cost adjustable timing motor that I could buy on the market today. And since I want to go racing in the dirt with it, I just couldn't see myself running a $100 motor. So I was able to get these fairly cheap off eBay, and you can probably get them cheap off other sources too. The other reason I wanted is because this is a stock spec 10.5. Now, what stock spec means is that a motor, say 17.5 motor, that is a stock motor, and a 13.5 could be stock as well, but at the 10.5 what you get is sometimes they make them with a stock rotor in them, and sometimes they'll make them with a modified rotor in them. And the difference between a stock and a modified rotor is the modified rotor is much stronger, gives you way more torque. And since I'm running off-road, I want more of an RPM based motor, so the Rocket RC 10.5 is perfect for what I want to do with the spec rotor in it. So what I wanted to show you, I got two of them. I have two vehicles I want to put them in. One is a two-wheel drive buggy, the other is a stadium truck. So what my plan is I was just going to give these motors a look over, and what I wanted to do was find the softer of the two motors, or the weaker of the two, put it in the two-wheel drive buggy, and the stronger of the two, put it in the stadium truck. So let's take a look at this first one, see what you get in the box. Now, probably if we could read this little product sheet, it would say, oh yes, it does, there's a little rotor size, and I think that the 10.5, you can barely able to see it. It tries to show you that it comes with both a spec and a mod rotor in 10.5, but it's so small you can barely read it. So you get your basic instructions. It tells you how to run the timing, it tells you how to adjust it. Turn it counterclockwise will take timing out. Turn it counterclockwise adds more timing. So you get a little instruction sheet. You get a purple end belt motor. You can see that these were, even though they're an older motor, they were really advanced. Has the two sensor ports on it, nice purple anodized. It's kind of open, which is why I'm a little bit worried about running it in the off-road. Did it come with any cable? Wait, aha! Came with a little ribbon sensor cable. Perfect. So this motor shall forever be known as Motor 1. Let's put it on the Sky RC motor analyzer just to see what you get straight out of the box with one of these. Plug it in. We'll see what kind of timing it has. As you can see, I just opened the box, so I'm a little bit unfamiliar with how the tabs are. They have big solder tabs. I think I'll be able just to clamp underneath between the motor and the tab. Hopefully that doesn't short on anything. Take a look. Okay, so let's try the timing. Now for motor timing, I don't really care what the timing is right now. what I'm looking for is just that the average is close. So we can see it's only 32 degrees timing, but look, we have a 30 and a 33, so that's a 3-degree spread across the different phases. But the timing is set very low. 30 degrees is quite low. So let's just write that down on a piece of paper. The timing: 30, 33, 32. Oh, and before I take it all apart, I'll just run the kV in amps. Something with such low timing, I bet you it hardly has any. So it's quite high. 3977 kV, 3.6 amps. So you can see with the really low timing, there's not a whole lot of amps. Okay, motor 1. Let's try motor 2. Ribbon cable in the box. There's motor 2. We'll just plug it straight onto the analyzer. See what we get out of the box. Okay. Let's go over to motor timing. Sounds like this one actually has more timing. You can hear it spin up quite high. Let's see what motor 2 has. We're looking for, this is 34 degrees. Let's see how, 34, 34, 33. So this has a very good sensor board on it. Can't get much better than that. Only 1 degree off on one. Let's just see what it does on a kV test. Let's let it rev up. And this is 3985 kV at 3.6 amp. So they must tune them at the factory. Here are the numbers we got so far. So far we see one sensor board is a little bit off than the other. The other is almost perfect. And it has 1 degree more timing, and you can see slightly, ever so slightly more RPM. But we're going to tune these after. Next thing I want to do is test the rotor. So let's put this over in its little holder here. So to test the rotor, we need a rotor tester. And why am I testing the rotor? Because I want to check the torque of the motor. So let's take motor 1. Let's get a 2mm wrench and let's take it apart. And we'll also get a chance to see what's inside. These feel like steel screws. They don't come out very easily. We'll see if those stick to the rotor here when we get it out. Now, the reason I bought this was because it has the SPEC rotor. So what I'm hoping is that a good stock rotor is about 1680 in gauss. If you get a rotor checker, it'll be about 1680. If you get a 1700 plus in the spec world, you're paying a lot for that type of. All right, so we see that there is a little bit of a little shim. I'll put it on the white there so we can see. So we get the front, a shim. I think there's another shim on the rotor. Now what I tend to do to help me deal with these So I'll put a pinion on it, because a pinion gives you something to hold on to while you're wrestling with the rotor, because they're strong. Let's see what we got here. Let's pull the rotor out, or push, I guess, because on the sensor side you can see that there was a shim in there, and just so we had a shim in the front, a thicker one in the back. Now we can pull this out. This is the stator. You can see soldered connections. Soldered connections. So this is actually a nice little stator. Put that over there. Now, what do you test? You can see that this is labeled Surpass Hobby. So Surpass Hobby makes these rocket motors. Not sure that it says on here. Oh yes, it does. Surpass Hobby Rocket RC. Right. Oh yeah, and there was a big shim there in the front. Great big one. Then there was this little guy, and then on this end there was this little guy. Okay. To test this, we need a different tool. It's called, now this was a tool made by Racers Measurement Systems. It's called the MMS Complete, and I use the rotor measurement mode. Remove rotor, push RMS button. Got it. Now there's a bit of noise in the air. I'm not really going to be finicky with this. What I was hoping to see was this number. I was hoping to see this number very close to 1400, 1500 for a low torque motor. And you can see it's 1700. Now this little rotor would have been super expensive. Super expensive to buy that. To get a 1700 plus. If you were racing touring car or something on road, you would be begging for this rotor. But for me, I wanted it to be very mild. But in the end, I got something very wild. 1750. Woo! So I'm just going to rate rotor 1750 on it. So that is a high torque rotor. It's way higher than I expected. Let's put that away into my box. Now when you get loose rotors like that, they can just go flying, so you got to be careful. Okay? Oh, let's just double check that screw. Remember I said I thought it was steel? No, it's aluminum. Aluminum screws in the can. Very, very good. So those are aluminum can screws. Hadn't really seen that before with a you know, $50 adjustable timing motor. It was tuned right out of the box. Okay, I'll just put these aside for now, these little shims. Let's open up this one. Turn this off for a moment. Let's see what's inside what we now call motor 2. What I'm looking for is something that's about 17 or around 1500 gauss. That's 1750, super strong. So if you want this is even the spec motor is a good motor. I would imagine. I wonder what the modified would have been in this rocket, Surpass rocket. That is something. I have some 10.5s that come from Surpass that have had over 2000 gauss. Surpass makes very good motors, and their V6 very hard to beat because they come with such powerful rotors. Okay, so this has the same thing as a shim on that side. I'm going to put a pinion on it help me deal with it. This is my thing. Because these magnetic rotors will sometimes hard to deal with. Okay, let's take off the sensor side, and we know that sensor was good. Came with 2 little shims on the sensor side. I'll reshim it anyway. What I like to have is 1 millimeter of space between the rotor and the sensor. Again, nice solder joints. Okay, that's motor 2. Let's see what we got here. Now, let's turn on the MMS Complete. Put it in rotor testing mode. Push the button. Got it. You can see it's at 5. It's because I'm waving rotors around. But I'm not interested in a... But look at this. Just, you know that video? Look at this. Just look at it. This is a 17... Oh, I keep moving it because I'm picking it up. But you can see that we get a 1784 reading easily without hunting too much for the sweet spot on this rotor. So I'm going to call this one a 1789. This is like, if you're looking for a good motor, I think we found it in the Surpass V3 for the price of them, about 50 bucks shipped. Okay, now the last test I'm going to do before I put these back together is I want to test the resistance, and I have a separate tool for that. This is the show and tell tool day. We didn't realize it when we first tuned in, but that's what we have. And to test that, what I'm going to use is this, and it's on a short leash. There we go. It's just stuck. This is a little Phantom Fax Machine 3, I think it's called. And what it does is it tests resistance and it tests inductance. Now, resistance everybody all knows and loves. It's just how much resistance is there in a piece of wire. Now, inductance is a little not as well understood, but it is how much power does it take to create a magnetic field, basically, is what it does. It has a time component, and it's measuring how long it takes to, how much power is used to create a magnetic field. It pulses it and such, so you can look up the exact specification on what that means, but that's why there's 2 different things. And when you test inductance, it's best to do that without the magnetic field or the rotor in it, because since you're building a field and collapsing a field, it's better to test that with no rotor in the way to interfere with that. So I just want to do some quick tests on this, and what I'll do is maybe I'll just do one. So this can test 1 pole, or it can test 2 poles. 1 pole means going from a solder tab down to the collection ring. 2 poles is across 2 solder tabs. So I might switch mine to 2 pole just for the ease of a test, and we can kind of see. Let's do our inductance. That's what happens when you do things live. 0.29. That's what we had before. Perfect. Let's do our resistance, and this time wiggling the connector to get a better connection. It says 7.3. Let's go to the next slot. So 7.3 to beat. First you test inductance. 0.3, which we saw before, so that seemed to work. Now resistance. Wiggling the probe. No, it's 7.2, 7.3, 7.4, 7.3. Okay. So, if those truly are the measurements, the one with the highest inductance and the lowest resistance is the one that you should choose for the most efficient motor. And that was motor 2. Same resistance, higher inductance. That means it took more power to create the magnetic field. Kind of gives you an indication that the magnetic field is stronger since it took more power to generate it. That's the theory anyway. I just want to test it against this very old 10.5. I kind of use it as a standard to measure against. Let's test its inductance. This is one of those old red motors. 0.032. Now let's test its resistance. And its resistance is 8.2. I don't know if you can see that. This little screen is terrible. So these new V3s have a much higher or much lower resistance than this old stator. This was an old red motor, just a stock motor, but you can see with the improvements that they made, these V3s are great. So what I'll do is I will pause the video now. I'll put these motors back together, and then I'll put the best parts into the number 2. So the best parts are number 2 sensor board, number 2's rotor, and I'll just write down the resistance and inductance. So basically motor 2 was the best out of all of them. Okay, so I'll pause the video, put it back together, and then we'll do maybe one last kV measurement test of the motor 2, and then we'll call it a video. See you in a moment. Back. I put the motor together, but I ended up not using this one little shim that was close to the sensor board side. Actually, the rotor was quite a bit too far from the sensor by about that shim. So what I did is when I built the motor, I didn't use it. Let's just try the motor timing here. Now that it's all back together. This one here had a motor timing of about 34 with a very close spread. This one here has 34, 32, 33 now. I might have to figure around with it, loosen the back screws and give it a little turn. And let's just double check the kV, that it's still back where it was. It's actually a little bit higher. 4,000 kV compared to the 3985 before. So shimming that little sensor actually helped it a little bit in for the RPM department, and 3.8 amps. So there we go. What I thought I was getting was just an old motor that I could run in the dirt that'd be nice and mild. Turns out that these Rocket RC V3 Pro stock specs, these are a really good motor. Lots of power, lots of torque. The rotor in these things is incredible. You'd pay a lot of money for that rotor. It might actually be worth buying one of these to put the rotor in another motor. Anyway, that's my review. I'm going to go install them in my stadium truck and my two-wheel drive buggy. And I hope that you liked this video. If you got something out of it, click like. Comment if you had any questions about the motor. And subscribe if you want to see more reviews like this. Thanks, and we'll see you in the next video.